Basically, engineering, any problem of engineering can be solved by three different methods. That is analytical method, numerical method, and experimental method. And if you go for analytical method, it gives 100% accurate results. If and that is why that is what we do it by technical formulae method. And if you go with numerical method, numerical methods are basically you adopt with a software and do some approximate results out of it, but they are not accurate. They're not 100% accurate, but it will be especially used to find complicated problem solutions. And this is experimental solution, like if you want to find whether the answer, whether the solution whatever we have got is correct, we can find it with the help of mathematics, sorry, experimental method. And that gives you little accurate results, and it is time consuming and a lot of cost involved into this experimental method, but still every now and then process need to be executed by experimental method to figure it out whether the results are correct or not. And this is how an example of analytical method: you take some simple beams and apply some moment of inertia, deflection, find the values of deflections and maximum stress intensities on it. That is what basic problem solving method, or by using a formula. That is what we have discussed in the previous stage. If we start with CAE, computer aided engineering, that's what we are going to discuss, hypermesh. But before going to that, you need to understand there are three different processes always will undergo in all the CAE process, that is pre-processing, post-processing, and processing, right? So in pre-processing stage, what we do is we make up the material in order to post-process. Like we'll mesh it, we assign the properties, we apply loads on it, everything. 80% of time or a project will be consumed in pre-processing itself, and the rest will be 20%, and it will take little time. That's it. In post-processing, in processing, there are different solvers we'll be having, and these are the examples and which are especially used in hypermesh: OptiStrut, Radius, ANSYS, Nastran, and Abacus, and rest of them are there. And most of the time we'll be working on the OptiStrut and Radius, and sometimes ANSA as well. And post processing will be able to find the results, we'll be able to stimulate it, and we'll be able to interpret the results with analytical solutions. Before going to the process of hypermesh, you need to understand how you will be able to tackle the mouse. So these are the controls of the mouse you can see over a screen, and it would help you. And these are the shortcuts, uh, like they especially used in order to go and search for the key and do it. It will take little time. In industry, everyone needs the project need to be completed within a stipulated time or less time, so you just need to go with these shortcuts so that it would help you guys. So before going to the meshing part, I'd like to take up some part of meshing guidelines, how you need to mesh it, how you need not to mesh it. This is the important criteria you need to understand before going to meshing. Like always, if the length is very high, always try to maintain two rows of elements instead of one. That's what it is written over here, right? And that's what on a fillet always try to maintain two rows of elements. If at all element size is failing, then it is an exceptional case. And always try to make the slit with a washer. If at all the washer length is very minimal, then try to go with the even flow or in the direction of the element size itself. As you can see the two differential values over here, if you want to check, I'm zooming it out, right? This is how you need to make it. Instead of making it diagonalized or perpendicular to the direction of the alignment of flow, or you instead of that you make it as parallel one, right? Next, yeah, that's what we have discussed. Try to uh, make the feature available. Try to mesh the feature as it is. Don't try to toggle the lines so that how awkward it looks. See, as it is a feature one, but it is looking like a flat surface, so it would disturb the surface, and analysis result would be a different answer. And try to maintain a stiffer like this. These are the guidelines you need to follow. Always try to maintain even number of rows and even number of elements on the washer. um, that's what we have discussed over here as well. Try to maintain two rows of elements and align them properly. Instead of having zigzag way, you can align them in a proper direction. So these are how to capture some beads they have given, and how to capture it. Instead of using quads, you make it a unidirectional tria formation, so that it would help us to minimize the stress intensity. This would better or enhance the element size. Next, and you can see you should not maintain or make this tria onto edges. See, this is the best example. I can show it, right? So always maintain even number. So if you can check the washer element, it should be greater than 6, and always try to maintain, and no tria should form on the edges of the washer. These are the basic guidelines you need to follow before you need to go to meshing. I hope you guys understood everything. And before we start with the meshing, please do subscribe to our channel and like it, share it.